I'm using the first math technique that I'm going to be doing is substitution. In reality, when I actually solve this by myself, I sort of mix and match various techniques. Or if I'm using a computer program, I'll set it up probably for Cramer's rule, which is the third technique. But otherwise, I'm going to just do pure substitution. Some of you already know how to do this. You can do it in your sleep. Some of you struggle with this. And so this is, well, for those who struggle. From the first method right here, I had these three equations right here. So let me just start out writing these equations. And one other thing I'm going to do here is the more I have to write, the more likely I am to make a careless error. So I'm just going to let the letter A equal current sub A, B equal current sub B, and C equal current sub C. And so my first equation here, I have A plus B plus C equals 0. The next equation I have down here is going to be 38 minus 9A plus 4B equals 0. And then the last equation, 47 plus 4B minus 9C is equal to 0. And so now to solve. When solving something like this, in substitution, I need to solve for an unknown in terms of the others. So I'm going to first start out with this one and solve for C. It doesn't really matter which one I pick, but I'm just arbitrarily picking C. So C, keep that here, and I take the other two to the other side, equals negative A minus B. I now substitute that in for C right here. There's no C in the second equation, so that stays as is. So 38 minus 9A plus 4B equals 0. This equation right here becomes 47 plus 4B minus 9 negative A minus B equals 0. I distribute, so this becomes 47 plus 4B plus 9A plus 9B equals 0. And so I end up with 47 plus 9A and then plus 13B equals 0. Let's say 13B. Let's see if I can write that more neatly. So now I need to solve for either A or B from one of the equations and plug into the other. And so what I'm going to do is solve for B here. So I get these to the other side. 4B is equal to 9A minus 38. B becomes 2.25A minus 9.5. I now substitute that in for here. Now, some of you look at this and you immediately see a shorter way of doing this. That's fine. I'm not forcing any particular technique. What I'm suggesting is learn a technique if you don't have one already and run with it. So as I plug into this one, I have 47 plus 9A plus 13 times 2.25A minus 9.5 equals 0. So I have 47 plus 9A plus 29.25A minus 123.5 equals 0. I've got those and these. Let me combine my A's here. So 29.9, so that's 38.25A equals, and then those combined, so that is negative 76.5, and so I'm just going to add that to the other side, so I get 76.5, and so then 38 divided by the coefficient here, and so A is equal to 2. Once I have that, well, I have a formula for B right here. That's equal to 2.25 times 2 minus 9.5. The advantage of this technique is at this point, it's simple because I have an equation for the other two already. 4.5 minus 9.5, which is equal to negative 5. And then C is equal to negative 2 minus negative 5. So C is equal to 3. And so in terms of the answer, the current A is equal to 2 amperes. Current B is equal to negative 5 amperes, and current C is equal to 3 amperes. If we look at the original problem, we had this setup. The current across the 3 ohm So I sub 3, the one going across the 3 ohm, that was what I labeled as I sub A. And I said it was going to the right, and I had A is equal to 2 amperes, so it's 2 amperes to the right. The current flowing across the 6 ohm resistor, well, I had defined IA to be going like that. And so this would be 2 amperes going to the left. The current flowing across the 4 ohm resistor, I said it was going up, and I labeled that as IB. IB was -5. So I can put down -5 amperes going up, or I could also write 5 amperes going down. Either way, they are both correct. Please do not mix and match. Do not say -5 amperes down or +5 amperes up. It is -5 up or +5 down. And then the current flowing across the 9 ohm resistor I had defined as going this way, and I ended up with a +3, so it's 3 amperes that way. If I wanted to know, we'll just take this one right here. What is the potential difference across that? Well, I know that's equal to I times R. This is across the 9. That is 27 volts. The error where most students make their mistake on this one is knowing whether it's positive or negative. Recognize if I'm going with the current, I'm losing. So the potential drop across the 9 ohm resistor is -27 volts to the left in the direction of current, or +27 volts if I'm going to the right. But if I'm going with the current, I lose potential. One or the other.